So we're going to start a lab in a few minutes. So I'm just first going to introduce myself, introduce some of the concepts that we'll be seeing in the lab, and then we'll get started with the lab, which should take about 1 hour. So I'm Nic. I'm a developer advocate with Ondat, and I've spent probably about, I'm getting old actually, 15 years in the data center infrastructure industry, from ISV to service provider to hardware vendors. And I spent probably about the last 5 years working on Kubernetes, but still more on the networking side, so CNI. Now more on the storage side. Really enjoy coding, DevOps, and automation tools. I love metal and I love running, and I sometimes love to do both at the same time. Not playing music, but listening to music. It will be quite hard. Anyway, so for today, we're going to focus on building GitOps pipeline for stateful application and also adding some notion of policy as code with Kyvern on top. But just before going into it, I just want to take 1 minute to talk about the states of stateful application in whether it's running them in container or running them in Kubernetes. So if you look at this report, which is coming from Datadog, probably late 2021, it shows the most popular images for running container. And out of 14, you see that more than half of them are actually stateful containers. So stateful meaning that they have to persist some sort of data to disk. So we have Redis, Postgres, RabbitMQ, so MySQL, Mongo, Kafka. So a mix essentially of databases and message queuing solution. So there may be multiple reasons why people do this, because we're not even talking about Kubernetes yet, right? It's just container images. A couple of reasons. One may be collocation. So people used to run their stateless application as part of container maybe orchestrator or directly on Docker. And most of the time you will find the database is sitting maybe in the cloud. And with a mix of failures in the cloud, or whether it's also latency, it's easier to get your application collocated with its database, right? A lot more performance. And because of the inherent Kubernetes functions in terms of disaster recovery, scheduling, and just resiliency, it makes sense to run those stateful applications into Kubernetes, but as stateful sets. I'm not going to explain what stateful sets are in detail, but essentially, to make it short, it's the best way to run a stateful application in Kubernetes because it provides network stability. A particular host name will stick with the container, whether it gets restarted, whether it fails. It's the same thing. There is a stability. When it comes to installing it, to scale down, scale up, there is a specific order of operation that is respected by Kubernetes. So it makes really sense to run now stateful application in Kubernetes because we have the tool sets required to run it as enterprise-grade features. So you can also check this report from DoK, which you can find on dok.community. So it's a much more comprehensive report than that. But one of the features I wanted to highlight here is what percentage of your organization's stateful production workloads are running on Kubernetes. So you can see that if you remove the 24%, like the vast majority is between, let's say, 25% to 100%, with probably this slot, which is the maximum, between 50 and 74, which is a lot. And it's not like 5 people, right? So it's 502 respondents from different various enterprise sizes and different verticals. So across the board, the trend is really to run stateful application within Kubernetes because simply, the platform has matured enough. But now running application like databases, we're going to see it in the lab. We're going to be using an operator. And why does it make sense to use an operator for databases is for the simple reason that these patterns allow you to represent anything as an object, whether it's something living in Kubernetes or that is not living in Kubernetes, representing that object as a particular first-class citizen inside Kubernetes. So here, just to translate it into something a bit broader, one example would be you create a a custom resource within Kubernetes, which is just an extension of the existing API. And the operator is essentially a mix of the custom resource itself, as well as a custom controller. And the principle is to have the custom controller react on some operation on the custom resource. So typically CRUD operation, so create, read, update, delete. And as operations are done on those resources, then the custom controller will watch them, and depending on what type of operation is performed, then the custom controller will do some sort of automation. So ultimately what you could do if you want is, for example, let's say in AWS, if you want to represent an instance within Kubernetes and automate the creation of AWS instances and manage the lifecycle of instances within Kubernetes, what you could do eventually is create a custom resource that is representing a virtual machine or an instance object, and then use the custom controller to control how you manage the lifecycle of that object. So let's say if you create a instance as a YAML file, in alignment with the schema that has been defined for the custom resource. So typically a couple of fields represented as YAML. As soon as this resource gets deployed in Kubernetes, so kubectl apply that particular resource, then the custom controller can react and effectively create the automation workflow to create the virtual machine in AWS. So suddenly what you have, you can use Kubernetes just as a generic automation tool using YAML as opposed to, for example, a Terraform TF files. And just by using the traditional Kubernetes native language, you can also now not only automate Kubernetes, but you can also automate external components, right? And that's exactly what we want to do with a database. So with a database, you just replace here AWS, Google Cloud, and Azure by your, pick your favorite, MongoDB or any message queuing solution like Kafka. What it will allow you to do is, as the stateful sets or the pods get deployed, you can then build the application on top. Because if you create a stateful set, what won't happen is the database won't be building itself by just magically. So you need some sort of knowledge encapsulation to build the database as you are deploying your pods. So effectively, as the stateful set get deployed into your cluster, the database operator will make sure that for, let's say if you have 3 replica to create a 3-node MongoDB cluster, the operator will make sure that the application that is sitting on top of those pods are forming the cluster in a healthy state. If you scale down your stateful sets from 5 to 3, for example, the operator will also make sure that the cluster now is healthy as a 3-node cluster, and then also provide other features such as backup, upgrades, all that, essentially encapsulating the knowledge required to manage the lifecycle of your database or your message queuing bus. But there are also challenges with operators. So first of all, custom resources are just an extension of the Kubernetes API. And every vendor has its own way of, let's say, maybe if you want to call your storage, that's fine, but maybe another vendor will call it, capacity provider, all these kind of things. And this is by design. It's an extension, so by default, there's no standard. You extend it how you want it. So there's no agreement between database vendors to have a specific schema to help you build, your database configuration. Another issue is that the moment you realize that there's an operator pretty much for everything, it becomes like a package manager in the end. So that's fine until the moment where you need to start troubleshooting things. And if you end up with hundreds of custom resources, you don't know what they do, you don't know all of their parameters. Documentation is something that's also lacking for most of the vendors. Of course, you can use kubectl explain, but that won't help you too much. So it's like VMware at the beginning when people discover virtual machine, they started to spin up virtual machine for everything. The risk is just to install, Kubernetes cluster is not your MacBook, right? Or it's not your iPhone. It should not be like a replication of App Store. Essentially, this is what it means. Another issue, the supply chain control, quality control. A lot of the operators are provided by third parties. So the question becomes for enterprise, how do you make sure that you can trust those third parties, right? So it's something that is quite challenging. Also, the custom resource validation for compliance and best practices, again, it's because it's related to the fact there's no standard. So how do you want to apply, best practices and guidelines if you don't have any standards? It becomes like a one by one, case by case, right? So it's really up to the Kubernetes user to maybe share with the community what they have done. If you have interesting use case, share it with everyone. But that's quite a gray area. There's not much there. And then finally, documentation. This is personally the one I struggle the most with, because your use case will be for sure different from what is stored on GitHub examples. So you will find a lot of different small examples. Sometime using GIB for gigabits or gigabytes, and sometimes you will find GI. So if you make a small typo, you end up with the operator not working, and you can spend days troubleshooting this. I even have one time where one of the specific version they switched from that was a megabyte to gigabyte. So I ended up trying to deploy a 1 petabyte database in my Kubernetes cluster with 10 gig of space. So it was not really happy. So yeah, there are some challenges. Operators are good, but use at your own risk. That's essentially what I'm trying to say. Okay, so now quickly on the policy as code. That was for the operator side. So policy as code with Kubernetes, I think should not be called policy as code. It should be called policy as YAML. Although it's very difficult for me to write YAML every time, because every time I write YAML, I'm under the impression like a child is sacrificed somewhere in the world. And yeah, but this is what we do. I've got a love-hate relation with YAML. I'm very happy when it's working, but sometimes I'm spending like hours just because I have one space on the 1,000 lines of YAML, and you have to find the indent that is wrong. But still, to build policy is quite easy, and Kyverno is actually a very good tool to do that, as opposed to other solution like, I'm not saying OPA is not good, or it's just that the difference here with Kyverno is Kubernetes, meaning that at the very foundation, it looks like a manifest that can be, any pod or any application manifest. It's not too different. But basically, the requirement for policy as code within, whether it's Kubernetes or outside of Kubernetes, the goal is to decouple the validation of enforcement from directive decisions. So it's a long sentence just to say that you can have your policy on a Git repository, and then you can have a process like an admission controller or anything in the cluster that will take those policy and eventually apply them to the cluster and verify that your manifests are aligned with those policies. Or Kyverno also provide a CLI, and we will use both during the lab. Both the CLI, which is more for a pipeline kind of style, meaning that you want to check the conformance of your application before deploying the manifest into the cluster, which makes sense. Or you can also have the policy checker and potentially the admission controller using as a mutation admission controller in cluster. But I would say we're going to combine both GitOps and policy as code. And the principle of GitOps is to have the single source of truth within Git. So one could argue that the moment you modify manifest coming from your Git repo into your Kubernetes cluster, and if it doesn't match exactly what is in the Git repository, it's not really GitOps anymore, right? But still, if you want to implement guardrails, that's a good way to do it, right? What else? So can be Kubernetes. It's personally my preferred option. Having worked with both OPA and Kyverno, I felt like it was going from, I don't know, like a very old car, cheap to a Ferrari that is super fast, and the learning curve is quite small actually. What else? Yeah, and optionally you can mutate the input. We're going to do that in the lab, but I'll let it up to you if that's a good idea or not. There's also now you can see more and more vendors or solutions. So OPA Gatekeeper is one. Kyverno Daytree is also one. Just to give you a quick overview of how the process is working with Kyvernal. We have the two validation, the two webhooks here, where you can insert, let's say, an external solution to Kubernetes to do some things. Like before, this is the workflow from an API request to the Kubernetes API server. So it goes through various phases, and there are two hooks where you can do stuff. There is a validation admission controller, webhook, where basically what you can do, so you will have a request that is sent to an HTTP, it's HTTP callback, and the external system will tell back the Kubernetes API if we want to allow the manifest to get applied and installed in Kubernetes, or the object installed in Kubernetes or not. Mutating means that you will change some of the values that are part of the manifest, right? That's the key differences. So this is the webhook part of Kyvernal, and then outside of this, you have a couple of features. So you can generate new, webhook configuration, secret. So the policy management there, and you can do. The next slide is about different features, but essentially that's about it. You have a controller there, two controllers, the generate controller and the policy controller that are in cluster. So this solution is only valid if you want to check for manifest once you deploy them into the cluster, not like as part of the CLI. So a couple of interesting features. So we've talked about validation, mutation. It both supports JSON patch and strategic merge patch, which is just a way to say you can go more granular depending on what you want to do. Either, let's say, replace a full array or full table, or a particular entry within that table. That would be a JSON patch, for example. So validation, mutation, you can also generate new resource on demand. If you need to. Precondition is nice because in terms of the admission review, it's what you do when you get the request from the webhook. You will have a payload. You can reuse some of the payload information to build variables within Kyvernal and reuse those variables to create your policies. So it can be quite dynamic depending on the payload you get from the API server. Two things more. You can also do image verification. It's using cosine. And this one is, I thought about you. This is the James path. This is the best path. So basically, this is the name of the guy who built this. He's called James, right? And this is a language that is a bit, if you have use cases that involve a bit more than YAML, then this is the thing you will use. It's a lot easier than Rego. It's not even a language. It's a way to express some data, right? It's not really a programming language. It's a data language. Okay, so what we are going to do today is exactly build a GitOps pipeline. So the difference between a GitOps pipeline and a normal pipeline is probably this part here. So normal pipeline, it's from there to there. You have application code. You build your application into a container. And then typically, if you want to deploy it into Kubernetes, you want to create some sort of customization. So essentially, using the Docker or the container image and replace it in the appropriate location into your Kubernetes manifest, and depending on your environment, if it's prod dev, you may want to have different values into your Kubernetes manifest. So a tool typically to build this is Customize. So you can run Customize as a CLI, and then build your Kubernetes manifest in a different, can be the same repo if you want, but yeah, for our lab it would be a different repo. And then in terms of this is where the GitOps pipeline will start. Typically you have a solution like Flux that is sitting within the Kubernetes cluster. It's going to monitor the different Kubernetes manifests. And upon changes, it's going to, continuously monitor what is happening there as a reconciliation loop and reconcile the states between what is the intent here and what is inside the cluster there. So anything you change here without doing anything will get also changed into the cluster, right? So this is what you're going to build today. But actually, the only difference is that Flux support customize by default. So you don't need to run customize as a command line or as an extra step. You just specify a customization file into Flux, and that's basically it. So it should be quite easy to do. OK, that was it. So now we can start the lab. So to start the lab, you can go to this page, which is play.instruct.com/ondat, like this one on the top here. So if you go directly there, play.instruct.com/ondat, you will end up on a page with multiple labs, and our lab is this one, the Trusted Delivery for Stateful Applications with GitOps and Policy as code. Once you're there, you can just click and then start track. Right. So I'll do it with you at the same time, so you can follow along. So it says 6 minutes, but the labs are hot start, so it should be faster than this. There should be about 15 labs, something like this. So it may take a couple of minutes because we are also now installing Ondat as part of the automation part. In the meantime, is there any question on what I've mentioned before? No? OK. So once the lab is loaded, I'm going to go through the scenario, and then it's mostly, it's a quite driven lab, so it should be rather fast. So yeah, GitOps brings DevOps CI/CD pipeline to the next level by providing a single source of truth for your application states in Kubernetes using Git. And so this workshop will introduce you to the concepts of GitOps and Policy as code, and how to use them to build a stateful application in Kubernetes. So this is exactly...
Your timer's done a good impression of the Windows taskbar, which is 6 minutes, 6 minutes, and then 6 minutes start.
Yeah, it's because it's hot start. It remembers the last time I deploy it without the hot start. So it's not like showing any progress. We can make it a bit bigger. Here, maybe a bit smaller. So I'm going to start reading it, so it will leave people time to check it anyway. So the application we're going to deploy is just a two-tier application. We have the front end that is just a Flask application, and on the back end we'll be using a MongoDB database, 3-node cluster, and by using an operator. So we'll install the operator as well. So by completing this challenge, there are actually 3 different challenges as part of the track. And the first one, we're going to be installing Flux, essentially, right? So Flux is a tool for keeping Kubernetes cluster in sync with sources of configuration and automating updates to configuration when there's new code to deploy. It's based on a set of Kubernetes API extension I've mentioned before, basically custom resources, which control how Git repository and other sources of configuration are applied into the cluster. So as new application code and manifest are pushed to a repository or set of repository, can be more than one, they are monitored by Flux, and the cluster state will be updated automatically. And as consequently, Flux allows you to update, create, or delete Kubernetes resources as necessary. So worth mentioning, it's a CNCF incubating project that I believe will be almost graduating soon.
Yes.
Right? Hopefully. I was categorized as adopt on the CNCF CI/CD Tech Radar alongside Helm, which is something. So after installing Flux, CLI will be running a very simple commands, and we'll have a GitOps workflow setups. So I don't have to go through GitOps because David explained what GitOps is, and hopefully at this stage everyone is kind of familiar with what GitOps is. Basically, single source of truth using Git, and then you have an operator sitting in Kubernetes that is reconciling the intent with the cluster state. So this is here, just a representation of the Flux architecture. What we're going to be building today is sources. So sources is where you define. Tell me if I did something wrong, David, right? Sources are where you define the Git repositories you want to monitor. So typically, this is where your application code is located, your application manifest, etc. The customization is where you define what to do with it. So you will specify, remember I talked about customize before. So the only thing, you will specify a couple of options, but one which is really key is the path where to find the customized overlay that will define your environment values, right? So once you have those two configurations that are defined, then that's pretty much it for a simple configuration. So of course you can have multi-tenancy, it also supports Helm release as opposed to customization. And yeah, there's essentially a Helm, customization, and what else? That's image, yeah. You can also update image, build image.
Oh, you can watch image basically
changes and replace them.
In a registry, and then basically it looks for a change and it says
okay.
And you tag it will pull it automatically in your image.
Yeah, no, that's very nice. Okay. So images is also something you can monitor directly on the container registry. So a couple of requisites. So here we're going to be working with GKE. So the cluster, the first thing you want to do is get familiar with your cluster. So this is a 3-node cluster here. It should have been provisioned for some time here. Then what we're going to do is download Flux CLI. So it's not directly installing CLI first. We download the CLI and just check that Flux CLI is there. So we have here 28.2, which is different from yesterday. It was 27.4. Good. And then you can check that Flux meets your environment meet the prerequisites. So here it means that this is perfectly fine. So here you will need a GitHub account with a particular token. So the thing to notice is that Flux, to install itself, is using GitOps, which I find quite smart because it's like eating your own dog food, right? So what's going to happen is it's going to ask you for those credentials so that it can create a repo on Git, and then your task to bootstrap the Flux install would be to clone this repo locally, create the different customization and source file locally with all the information, then push it to the remote repo, and because Flux will monitor this repo, then it's going to get installed in the cluster, right? That's basically it. This is right? Okay, that's cool. Okay, so you need to get your token. So my token should be somewhere. So generate new token. You can go on GitHub. You have the instruction in the lab to generate a new token. So for me, it's just, oh crap, password. Use security key. I need to bring my key. It would be easier. Here you go. YubiKey is your best friend.
Until you lose it.
What?
Until you lose it.
Yeah, until you use it. Okay, good. So the only permission you need is this one. So repo. And that's basically it. So you can also change the time, put in maybe an expiration. And then from there, just go back here. I'm going to paste it up. Export your GitHub token here. This is good. Then also your username. And that's basically it. So now this is the command to really upload the repo on your Git, on GitHub. And this is going to install Flux. So copy paste this. Should take a minute. So you can see like here reconciling the source. So really using GitOps to install itself, to bootstrap itself. And so after this, what we're going to do is just clone the repository. And that will be in the next challenge, we'll build the source and the customization. So once it's installed, you should see this hierarchy here. So first we want to git clone. Here you go. And just use tree here. So just again, so it's more visible. So at the moment, it's quite empty. It's just like the internal configuration for Flux. What we're going to do is create just another app directory with the application manifest for a different environment. So once you're done with this, you can click check. Oops. Yeah, sometime if let's check, it's there. It takes some time to install. So you just want to make sure to use this command to check that all the pods are effectively running. So now it's running. If I do check, it should be better. Okay, good. So loading next challenge. Next challenge is just installing the source and the customization and deploying the application. So this one is quite fast. Let's start. So in this one, we're going to deploy the MongoDB community operator. So remember, so the custom resource is part of the application manifest, right? So it represents the configuration of the database you want to install. But in the first place, you need the operator so that you have a controller that can react when you apply the custom resource to Kubernetes, so that you have effectively a database that is created. So we're going to create the Flux source repository, which is the application and the manifest. Customization, which is specifying where to find the customization for your specific environment. And then we'll check some differences between dev and prod. So we have two environments, dev and prod. We have here the editor. So the editor has all the files. So if you're curious, and we're going to be using them anyway, you have for dev and prod, you will find the overlay here, and also the configuration and all the required manifest for the MongoDB community operator. But for now, let's deploy the MongoDB community operator. It's a lot of copy-paste. Here I'm explaining basically what I explained before in terms of what is an operator, what do you need one in the first place. It's just easy to manage a database with an operator because it facilitates the management of its life cycle simply as this. So here we just go into a directory and apply. First step is to apply the custom resource definition so that we have the schema that is recorded as part of the Kubernetes store, etcd store, and that effectively when a MongoDB custom resource will be pushed to Kubernetes, it's effectively a first-class citizen inside Kubernetes. So then we need to apply a couple of permissions on different namespace. We're going to create the dev namespace as well. We're going to deploy the prod application into the default namespace, and the dev version of the application into the dev namespace. Again, a couple of RBAC permission to deploy. A lot of copy paste, but it's just basically the foundation, just the requirement for the operator to be deployed in the first place. So here we are now in the critical phase, which is deploying the operator. And everything goes fine, then I should see the operator being there. So running here means that now we have the operator ready, which is watching for any new resource of type MongoDB community being created. Just to validate, if here it means that now we have this MongoDB community as a valid first-class citizen, as a valid type inside Kubernetes. Okay, now we are ready to create the different Flux resources. So the first one is the source for the dev environment. So we have a couple of information here. So a name for the object, the URL of your application manifest, the branch, right? So here we have the dev branch, the interval where it should, that should be used to get monitored. And then here I'm just writing this definition into the dev.yaml file. Same thing with prod. You can see the same repo because I'm lazy. The only difference is that is the master branch, right? So we have dev master branch for different usage, but same repo. And now we're gonna add some information within those two files, so the prod and the dev file. We're gonna create customization. So we have created source. Now we create customization. So the first one is for prod. Again, it's just purely YAML. And for dev, here you go. So here what we have, if you look at the customization command line. So again, you specify the source that you have named before, the path that is hosting the customized resources inside this repo, the target namespace, prune, meaning that if you delete something, then the resource that you delete in the repo will also be synced in the cluster, meaning that it will delete resource within the cluster. Interval by default, it's 10 minutes. You can also manually reconcile if you wish so. And again, we're just redirecting this to the file. And now, if I do tree again, I should see a couple of more things. So now you find the dev and prod, and if you display the content there, it should be prod, just basically what we have before. So the source with the type Git repository and the customization for prod and dev, right? So far we had been working locally. So at the moment, even though we have those YAML file, it's just text. Nothing has been added into the Flux repository remotely, meaning that Flux doesn't reconcile anything because there's no configuration yet. So the only thing you have to do is push it to the GitHub repo. And at some point, if you monitor what's happening, you will see that a new, here you go. If I got this, here prod and dev are being reconciled, right? And you should see already some container being created. So you can notice here the different, this is prod, we have 5 container. If I check the dev one, there's only 2. And also in terms of differences, we have 2 different storage class. So for this lab, I'm using Ondat storage class. And the difference between both is, so you know what, instead of showing you using kubectl, I'll show you using the overlay. Because the overlay, this is the intent. This is the single source of truth, where Flux is basically pulling all the information. So for dev, the Ondat storage class, you can notice replica is 0, encryption is false. And in prod, You can see it's 2 replicas and encryption has to be enabled. What else do we have? I think it's the main difference, right? That's basically between, oh yeah. Also for the prod, we expose the application outside of the cluster using a service type load balancer because we are in GKE, we have the GKE integration. So the cloud provider integration, which means that any service or any application that is exposed with a service type load balancer will get a public IP address from a Google load balancer. And so now the application should be deployed. It takes some time because it's a stateful set, remember, for the database, so it's sequential. The next pod only gets deployed when the previous one has finished. It's not like everything at the same time. So if I see here, so we can see the MongoDB one is still initializing, and so the application is, as I was mentioning, there's the front end, the database, but also I've got a job, a Kubernetes job that will probably run multiple times until it succeeds. It needs the MongoDB cluster up and running and healthy to write stuff in the database. So what the application is, so I've developed this quick application using the Marvel APIs. So the job is gonna pull some information from the Marvel APIs, so information about specific characters, populate the MongoDB database, and the front end will just display random cards with those characters and various information. So you can just specify -w to monitor everything. So still initializing the last, so the third node. And if I go to dev, same thing. So this one is still running. So because it's a job, eventually it will succeed, right? It's repeating, I think by default is 10 times or something like this. But at some point, as soon as the database is available, the job will catch up and populate the database with all the information, JSON information, like semi-structured data. Okay, so how does it look now for the prod? Okay, still running. So now that the database, you can see the 3 nodes are running. The next one should succeed. In the meantime, I'm also showing you what it has created from a PVC perspective. So the operator is also responsible for the sizing. And we're going to use this, custom resource. You define all the database configuration as YAML, and we're going to apply Kyverno policy on those database configuration later on. So same thing for dev. Couple of PVC there, and they are all backed by Ondat storage class for sure, as you can see here, prod or dev. Still running. Oh, completed, right? So you can see here the job has completed. So now I can just check the service, and we're going to check if the application is working properly. Here you go. So now you can see the public IP, external IP has been populated by GKE. So the application is running on port 8080. So if you open now a browser, I'm stressed. Is it going to work? Mm-hmm. Yeah, it works. Ta-da. But sometimes I've got some errors in the application, but on this particular lab, we tried. Yeah, these kind of things. I'm not sure why, but if you refresh, then it disappears. I'm using G-Unicorn. That may be the reason, not Nginx or anything like that. Yeah, so now it's working properly. So you can have, my daughter, she likes to play with this. Yeah. So she's saying that Dad is going to be in the next Marvel movie, but I'm not sure. Okay, so it's working. That's what we wanted to show. And I think that concludes the second lab. Now we have the third one, which is going to be around policy as code. And Jenki didn't, oh, she's like the big eyes. No, that's fine. Like another, yeah, that's fine. So check. Now, I should be all right, right? Yeah, good. So in the last part, what we're going to do is redo the same thing again, but by adding some guardrails. Guardrails with the admission controller, but also using the CLI like if it was a pipeline. So the first thing I'm doing in this lab is deleting the previous application, but remember, you have to also push the configuration on in the repo, because if I delete manually, Flux will reconcile and redeploy the application. So quickly, you pick this, paste it, and then that's fine. Push into Git, now Flux will sync with this, which is basically removing what is the different environment, right? So if I do like a 3 apps again, it's still, oh no, yeah, it's removed from the cache, not from the file system. Okay, so here, what we're going to do is we're going to put ourselves in the shoes of the, like the DBA, or there's not such thing as a DBA anymore for Kubernetes, I guess. But basically, a couple of rules, like housekeeping, right? The database must have an admin user with admin permissions on the cluster, all databases, and it should also be able to manage users. The PVCs attached to the database must have a capacity less than or equal to 10 gig, not more. The data must be encrypted in transit and at rest, and every persistent volume must have at least 2 replicas. And of course, quickly on this one, you can use Ondat story class for that, and this is what we're gonna do. So why I've chosen those 3 is because they are 3 totally different things. We have the database. So the database manifest is a custom resource, meaning that the policy as code is not, the rules and how it's applied, how it's checked is not limited to Kubernetes native resources. The fact that you have a custom resource also allow you to use the policy as code principle or policy as YAML principle to control not only Kubernetes native resources, but any custom resource, so representing anything, right? So again, the same way HashiCorp has Sentinel to control, policy that you apply on your Terraform resources. Kubernetes has a wide range of options, so Kyverno, OPA, etc., etc. But doing this in less than 2,000 lines in OPA would be amazing. So here we're going to see it doesn't require a lot of knowledge to do that. So the first thing we're going to do is use the validation policy within the CLI. So here I'm not going to be using Flux. It's just basically using customize, build the manifests as text files, and output this into the Kyverno CLI. So Kyverno take as input your application manifests, and is going to take as a extra parameter the directory where you have all your policies. And without having any cluster available, so completely off cluster, we'll be able to tell you if your application is conformant or not compliant, right? So there's a couple of things I'm explaining here, like in terms of the different validation, but essentially there's a couple of operators you can use with Kyverno, but nothing too fancy. It's not like it's a new language, it's just purely YAML. So now we're going to go through the different files for these policies. So we have first validate. We have 3 simple validation. So we want to check here that, here you go. There. We want to check that you have at least one admin user that has all those roles. It's just YAML, not too complicated. We want to check, the only difference, here again, it's also a custom resource type cluster policy. So cluster policy is your policy object. Encryption, here you've got, again, you specify the kind, if this is audit or enforce. So of course, I mean, enforce will deny the resource deployment into the cluster. You give it a name, where you want to apply it. So here we want to apply it on the storage class, and the message and the pattern. So here it's really simple. What you want to have is you need to have this line in the manifest. Like if you have encryption that is false, then it will match this pattern, but the value will be different, so it will be rejected. As easy as this, right? Quite easy. Same thing with number of replicas. And what I found very nice is that it supports those comparison operator as strings. And I find it quite magic. Like doing this as a string is I mean, that's a dream come true. And even better, like when I started to do that, I was, how can I do that? Because of course, this is not gonna work, right? Because this is a string, but actually it's working. I'm gonna prove it to you. So super easy. Try to do the same thing with Rego, and you're gonna probably spend more than 1 weekend. Okay, but now we have our production environment here. If you go back to the lab, it's gonna tell you we have to, the CLI here, we have to modify, right, the overlay. So we're going to be using the customized CLI to build the manifests, but at the moment our manifests are conformant. So we want to introduce some errors. So by removing one of the admin permission, changing the size of the data volume, and also removing the encryption. So let's do this. We want to put, so in here, production, so flux prod, then we want to go to the custom resource. So the MongoDB configuration, we're gonna remove the cluster admin section, and we're gonna put 50 gig here. Save. If you're on a Mac, Command S doesn't work, it's Control S, or click this little floppy that is there. So we have 2, and the third one, we want to have storage class to false here. So I've been a bad developer. I didn't listen to my fictitious DBA. So that should be it, right? So we modified the permission, the volume size, the storage class. So this is basically it. So yeah, you have to go to the right directory where the customize overlay is, right? And again, this time it's kind of simulating the command line you would use as part of a CI pipeline or CI/CD pipeline, where you just want a binary decision, so yes or no. So basically it requires, you can do a small script like checking the number of fail that will appear here. So here, again, customize build dots will produce a long list of manifests. Kyverno apply will look in this directory for the policies and just specify, yeah, it's just a pipe, so taking the result of the previous one as an input. And if everything went well, we should see 3 errors. Come on. Yeah, 3. So you can just, if this number is not 0, then you can fail, right? This is a binary decision. But it's telling you more, like it's telling you, okay, policy require Mongo permission on this resource failed because the user named admin must be created and have admin roles, blah, blah, blah. And then require encryption because the encryption is false at the moment, and also the volume size because it should be less than 10 gig. I mean, it's amazing. I mean, if you have experienced Rego before, I keep saying this, but it's just magic. Okay, so now we have validated that it's not good. So the pipeline, if this is part of the pipeline should fail and raise the, whatever alert, etc., etc. So now what we're going to do is doing the same thing, but in cluster. So meaning that so far, those YAML policies are just living as text files. So now we're going to apply those resources into the cluster. At the moment, if I do get cpol, which is cluster policy, I have nothing. So I don't have any Kyverno policy, although, of course, what you need has been done part of the lab automation. You see this Kyverno admission controller is installed in the proper namespace, right? So it's already ready to, I mean, I did the command kubectl get cluster policy, which means that it's a valid resource within the cluster. Okay. So we're going to apply the validate resources. So we have the 4 policies that have been created. So let's do this manually. So remember, the policy is enforce mode, which means that I'm going to hit an issue there, because if I do this, right, I will have an inconsistent application, because the application gets deployed. I mean, part of the application gets deployed, like config map secrets, the service, the deployments, or the front end. The job gets deployed, but the storage class doesn't get deployed, which means that the PVC cannot be created, and the database doesn't get deployed, which means that my application is broken. So you may want to use audit, but then you will have non-conformant application, deployed in your cluster. So yeah, it's a trade-off, I guess. But the point I'm trying to make is, yeah, if you want to validate, probably it's better to do it before as part of the CI/CD pipeline, as part of the GitOps pipeline, if you wish. So we have the result there. And as expected, if I do this, part of my application is running. But yeah, it's gonna fail at some point. I mean, the application won't work. Okay, that was one. So for the next one, so first delete the application that has just been installed. Okay, it's deleting everything. And the last part is about mutation, which is also quite interesting. So again, check the different policy that has been applied. I still have my validate policies. Now I'm going to apply my mutate policy, and we're going to take a look at them quickly. In the editor, you have the mutate section there. We have 3 of them. The first one is really about enforcing the creation of, the permission for the admin user. So here, again, this is where we use, how was it called? Preconditions, right? Preconditions and James path. So we have James path there, which is just this kind of new language. But it's quite easy. Right? It's not very difficult. It's not 1,000 lines. It's just basically a value. It takes like probably 1 hour to get. I'm not an expert, but it took me 1 hour to do that. So it's not really too difficult. Then we have, in terms of the storage class. So again, this is really easy. Type mutate. I want to do a patch strategic merge because I don't care about the fine-grain tuning. And this is it, right? Anything that has these fields will be replaced by this. So I'm sure I'm going to have 2 replica. I'm sure the encryption will be enabled. I'm sure to use XFS, which is the file system recommended for Mongo, and that's basically it. Right? And the last one is enforcing. Again, it's using a bit more. Not complex, but something a bit different, like standard YAML, using James path. And this time using JSON patch because I want to get more into the table and replace a particular entry within that list. So you need for this to use JSON patch. And that's the validation policies. So now if we go back to the console, the policies are now living in the cluster. If I go again and get cluster policies, they are all ready. So yeah, just a quick note here. This 5 gig here, now I'm applying it to all the volumes, not only the data volume, but all the volumes that will be attached to the stateful set, the MongoDB stateful set. So it's also a way to guarantee that regardless of the PVC, even if you had 1, 2, doesn't matter, you will have to have this size. Right? Okay. So the policies are there. So now again, we are switching back to Flux. So like before, we're going to create a source and a customization. New repo this time. So we're going to monitor the non-conformant repo, which has implemented what I have shown you from the editor. So the size, the permission, the storage class with no encryption. Everything is in this repo, like bad repo, bad. And we're going to ask Flux to take over that repo, monitor it, and then deploy it into the cluster. And we're going to see what happens, if it's getting deployed or not. So I don't want to mess it up. So okay, so the first one is the source. Okay, in the prod file, we have the customization again, still in the prod file. Just checking again. So now in the prod, we should have. You can see the non-conformant here on this Git repo. On this, still the same repo because I'm really lazy, just a different branch. And the customized overlay. So still using the prod overlay, but with bad, with non-conformant or non-compliant values there. Now we need to push it again to Git because this is GitOps, and hopefully customize is gonna pick it up. We should see appearing at the bottom here. And as soon as it's deployed, or maybe it won't be deployed, right? I'm not sure. Yeah, but I mean, the response is in the question. So yeah, normally now we should see that the volumes have been deployed with a different size. We should see that encryption has been enabled, but now we have a drift between what is in Git and what is sitting in the cluster. So you have to consider your priority. Is it to have a single source of truth, or is it to have a conformant cluster? Right? Or again, you can use the first CLI command as part of your pipeline. So here we have the sync in progress. So in terms of the pod, yeah, so again, it's the app will get installed. So you can see the MongoDB passed the test, the storage class, of course, because it's running, so it passed the test. If I do get PVC, I've got now my Ondat prod storage class that has been created, meaning that it also passed the test. And now the difference I want to show you is here. So this command is just using a kubectl with what JSON passed, just to show you like the result. So now we have 5 gig for the data volume, for the logs volume. If I check the storage class, which is gets storage class Ondat prod -o YAML, you can see that encryption has been changed to true. So basically, yeah, the mutation, the mutating admission webhook has changed, or rather Kyverno has changed the value that was first input as part of the Kubernetes API payload, the request payload. Okay, so that was the last part. And so hopefully I should check this and I should get a pass. So what is my gift to have successfully completed the lab? Where's Jenki? Yay! So I'm very happy with the lab because, of course, I did it. I created it. So yeah, so hopefully the lab was interesting. I think it's good to have this kind of hands-on, because combining different new technology like GitOps, Policy as code, and testing it live, it's always interesting.